Next, we want to take a look at the Public Works Department. Primarily, the assets that they deal with managing are related to the city's infrastructure. Not always, but in our example, the Public Works Department has a city-owned and operated water, sewer, and electric utilities. In Public Works, they need to know where the work is going on today, react to calls and incidents that are coming in, and at the same time be able to plan for the future. Using a repeatable hardware and software architecture, multiple departments such as Public Works implement Workgroup ArcGIS servers. This Workgroup Server provides a multi-user geodatabase to maintain key infrastructure and asset layers. Reference layers such as parcels and the zoning layer you just saw updated by the GIS analyst in the planning department are used from the Enterprise Geodatabase Warehouse. The Streets Division maintains the addresses, street center lines, and street network dataset. Prior to implementing the Workgroup ArcGIS server, they were using shapefiles and were confronted with lots of data management issues, such as single-user editing, scalability, and data redundancy. When edits were made, copies of the shapefiles, locator, and network dataset had to be redistributed, making it difficult to know which dataset was current and up-to-date. One aspect of a Public Works department is capital improvement projects. These projects are for repairing or resurfacing streets, installing traffic lights, building or expanding existing roads. Collaboration and communication is important between divisions in a Public Works department. The Streets Division doesn't want to repave or surface a road only to have the Water Department to go out a week later and dig it up again to install water service for homes. As shown a few minutes ago in the example with the Planning Department, a recent subdivision has been approved, and this change also needs to be reflected in the infrastructure managed by the Public Works Department. The subdivision may go through a series of changes as it moves through the plan, design, and as-built phases. Using versions in the geodatabase, alternative representations of the database for each of these phases can be created. As an editor, I can create my own, or I can share versions with multiple users updating the geodatabase. ArcGIS provides a robust suite of editing tools that allows an editor to enter highly accurate spatial data. New streets will need to be added for the subdivision, and there are many ways to get started drawing lines with the editing tools. New at 9.3, you can now directly enter decimal degrees or degrees, minutes, seconds using the absolute XY sketch constraint. I have a decimal degree coordinate pair from a survey-grade GPS of a known monument location that measured the beginning of one of the new street center lines. To get started, I'll enter the X, and if I specify DD at the end of the X coordinate, it will tell the editor to convert this decimal degree coordinate into the map units that I'm currently using. If I enter, the first point is entered into the sketch. Using a paper plat, or measurements from an engineering drawing, I can enter bearings and distances using the direction length sketch constraint. I can enter a direction of south 89, 145 east, and a length of 136, 731. I click enter, and now we can see I've entered the bearing and distance. If I right-click and finish the sketch, the street is now committed into the street centerline layer, and I can then update some key attribute information. I can continue entering the features one by one until I've updated every street in the new subdivision. This type of editing process is what we consider a long transaction and might take an hour, a day, a week, or even longer and can easily be accommodated with versions in the geodatabase. To speed up the editing process, I want to leverage the work a local engineering company has done by copying and pasting some of the features that are contained in the CAD drawing to update the geodatabase. So the paste is performed and the features are now inserted into the geodatabase. Again, I could update the attributes to complete that process. For the essence of time, I have a script which I'll run, which will simulate the editing process. Before I continue with the workflow of posting my changes, I send a note to the manager that performs some quality assurance and quality control processes to verify the edits are both spatially accurate and the attributes are properly updated. If I activate a specific version of the geodatabase and turn on the versioning toolbar, you can see that there is a new command that we've added at 9.3 called the version changes to help streamline the QA/QC process for someone that wants to compare the differences between two versions. For example, I want to compare the differences between my current edit version and the default version of the geodatabase. The version changes dialog lets the data reviewer easily see changes that have been made without first performing a reconcile with the parent version. For the purposes of this demo, I have an edit session open, but the version changes dialog can be used outside an edit session as well. Using this dialog, I can see the total number of changes. I can also see the individual changes for each layer, the inserts, as well as the updates to these features. I can select any record, and with that selected record, find out which attributes have been changed. I can change the display and actually see that feature on the map in its before and after state. If I scroll down the list and I select one of the updates, notice that in the alt name field, it highlights in bold the exact record which was changed and the values before and after the updates. Stepping back to the inserts, if we look closely at the attributes, we can notice that the address range fields have not been updated. As an editor, I might want to correct these, and the manager might let me know that these need to be updated and corrected before they're posted into the geodatabase. As you can see, this dialog is very functional and easy to use. The updates and corrections have been made, and now I want to post the edits to the default version of the database so that everyone in the department has access to these changes. The workflow is to first reconcile against the default version to pull any edits from other users to verify that there are no conflicts. If no conflicts are detected, you can post the changes back to the default version. The edits are now posted to the default version of the geodatabase, and any ArcGIS client application now has access to those updates. In summary, I have shown how ArcGIS Online can be used as a base map or reference to create new data in the geodatabase. How batch geocoding workflow has been improved with better progress reporting, improved performance, and a new tool for picking addresses from the map when interactively rematching candidates. Also, a few of the editing tools in ArcMap that have been enhanced, as well as the new version changes dialog for quickly comparing changes between versions. Finally, whether you're the only person doing GIS in your organization or just one of hundreds, the geodatabase is a highly scalable from a file to relational geodatabases to help you manage and maintain the data you collect about the patch of geography you know best.